Next is we have the domain and range of rational function. So when we say domain, it is the set of permissible values of x, and also we have the range is the set of all permissible values of the y for the rational function. So let's try to have some recall on how to make use or how to write the domain and range on various forms. We have the roster format, that is listing or enumerates the list of all values in the set. Example, we have the domain R of t r 1, 1, 2.5, 1.5, 1.75, and 2. You can also have set builder notation. So we have x such that x are even numbers from 10 to 20. This x is read as such that, so assuming that you also include odd numbers in the domain from 10 to 20, then you can write the domain of the function dx as x is an element of R, x is greater than or equal to 10 but less than or equal to 20. Then by interval notation, we have this is read as negative 8 to 3 union 3 to positive infinity, which means the values of the domain can take all real values of x except 3, because 3 here is not included. So let's try to have an example. So we have find the domain and range of the rational function. So we have f of x is equal to 2x minus 3 over x squared. So when you say domain, permissible values of x, in which, so sabi natin is the denominator should not become 0. So we try to assume that all values of the real numbers are or is all values of the real number, they belong to the domain, but we have some restriction. And where do we get this restriction? That is in the denominator. So we try to equate the denominator x squared to 0, or let's try to think what makes x squared 0. So 1 squared is 1, 2 squared is 2, 3 squared is 2 squared is 4, 3 squared is 9, and so on. The only number that can make this denominator 0 is also 0. So what is the domain now? The domain is x such that x is an element of R, x is not equal to 0. Bakit x is not equal to 0? Because if we try to substitute x in this expression, it will become 0, and take note the denominator should not become 0. Next, we find the range. So to find the range, we use f of y is equal to y, or we interchange, we change fx to y. So y now is equal to, or f of x is equal to 2x minus 3 all over x squared is now equal to y is now becomes y is equal to 2x minus 3 over x squared. Then cross multiply, we have yx squared is equal to 2x minus 3. And as you can see here, this becomes just like a quadratic equation. This yx squared transpose, that's negative 2x plus 3. So we make use of b squared minus 4ac, which is greater than or equal to 0, to get real solutions. This is the discriminant of a quadratic equation. So what is a? That is y, b is negative 2, and c is equal to 3. Take note, the discriminant should be greater than 0 to get real solutions. Because if you are getting imaginary solutions, and of course, that is the time when the value of the function becomes undefined. So we have to substitute negative 2 squared minus 4 times AC, negative b squared minus 4ac. So negative 2 squared is 4 minus 4 times y times 3 is 12y minus 12y. Transpose 4 is greater than or equal to 12y. Then divide by the coefficient of y. That will be 4 divided by 12. 12 divided by 12. And that is 4 over 12 is 1/3 to come up with y. So the answer is y is read backwards, or let's try to rewrite this. That is y is less than or equal to 1/3. So set of permissible values for y, we have the range is y is an element of R, y is less than or equal to 1/3. I'll repeat, we have the domain is x is an element of R, x is not equal to 0, and the range is y is an element of R wherein y is greater than or y is less than or equal to 1/3. Take note, lahat pwede dito, pera lang kay x, pera lang kay 0 for the domain. But here, lahat ng values na mas mababa kay 1/3, yun lang yung pwede. So kapag mataas na, let's say positive 1, positive 2, positive 3, that is or that does not belong to the range of the function. So as you can see here in the graph of the function y is equal to 2x minus 0 over x squared, the graph here is ito lang. So ito yung x values. All, lahat yan, pera except 0. As you can see in the graph, it does not intersect 0. Rather, papunta lang doon to the left and to the right. It is not intersecting 0 value for x. And the same case for y, all the values less than 1/3. So, nandiyan yung 1/3? Dito lang. 1/3 yan. Then, pababa, we have 0, negative 1, negative 2, negative 3, negative 4, negative 5, and so on. Belongs to the range of the function. Then, as you can see here, walang value for y na positive or greater than 1/3. Kasi nga, less than 1/3 lang siya. Number 2. Find the domain and range of the rational function f of x is equal to x minus 2 over x plus 2. I'll repeat. First thing we have to consider is the domain. And how do we have the domain? Tignan natin yung denominator and let's see what makes it 0. We have x plus 2. So you simply have to equate that to 0. X plus 2 is equal to 0, then solve for x. This x plus 2 equals 0, then x is equal to transpose positive 2, that becomes negative 2. So negative 2 yung hindi pwede. So let's try to have negative 2 here. Negative 2 plus 2 is 0. Therefore, the domain is x such that x is an element of R wherein x is not equal to negative 2. Ulitin natin, bakit hindi pwede kay negative 2? Kasi nga, kapag sinubstitute mo yung negative 2 sa function, that will become 0 or the denominator will become 0 and therefore the function will now become undefined. So, sabi dito, domain, lahat ng x or lahat ng real numbers kasali kay x, pwera lang kay negative 2. Next, we find the range. The same case, find y. We have fx is equal to y. So we now have y is equal to x plus 2, x minus 2 over x plus 2. Then, solving by cross multiplication, we have, that is y times x, then y times 2. That will be xy plus 2y is equal to x minus 2. Since that is cross multiplication, the denominator here is 1. So, x minus 2. Walang nagbago dito. And then, combine the similar terms, I think. That's x minus y. I arrange xy minus x is equal to negative 2y minus 2. Then, factor out. What is the common monomial factor for x, y, and negative x? That is x. To get y minus 1. So, recall x times y, xy, x times negative 1, negative x. And then, factor out negative 2 to come up with negative 2 times the quantity y plus 1. And after that, since we are solving for, we can solve for x here. That is x is equal to, that is divide natin yung negative y, yung y minus 1 dito. So we have x is equal to negative 2 times the quantity y plus 1 all over y minus 1. Next is we have the value y minus 1 in the denominator. So what makes it? We can have it as the domain or represent, just like what we did with the domain. We have y minus 1. Since y is in the denominator, what makes it to be undefined? That is, we solve for y minus 1 equals 0, and y is now equal to 1. In the same case, the domain, the range is y such that y is an element of R wherein y should not be equal to 1. Why? Because if we are going to have y value of 1, the whole of the equation will become undefined. So as you can see here in the graph, what's the domain kanina? The domain is except negative 2. Andito siya, hindi siya magta-touch sa negative 2, and except 1 also, ito siya, hindi niya ita-touch yung positive 1. Example 3, find the domain only, because this problem is, this function is complicated one. But we can have the domain only. That is, the denominator is 2x squared plus 7x minus 4. How do we have this? We factor grade 8 or grade 9. That is 2x squared plus 7x minus 4. Factors are, so try to factor the denominator, that is 2x minus 1 times x plus 4 is equal to 0. So find the values of x. So solve for x. The first factor is x is equal to 1/2 and x is equal to negative 4. In the same case, the obtained values of x are the restrictions, or these values do not belong to the domain. So the domain x such that x is an element of R, such that x is not equal to negative 4 and x is not equal to 1/2. So all the values can take the variable x except negative 4 and 1/2, because the denominator becomes 0 and f of x will be undefined. So we can have x is equal to 1/2 and x is equal to negative 4. So the domain is x is an element of R such that x is not equal to negative 4 and x is not equal to 1/2. So the interval notation can also be written as the domain is negative 8 to negative 4, negative infinity to negative 4, union negative 4, 1 half, union 1 half to positive infinity, wherein negative 4 and 1 half are not included in the domain. Next, let's try to find the domain and range of the rational function x squared. Fx is equal to x squared minus 3x minus 4 all over x plus 1. So consider the denominator. We have at what values of x will make the denominator 0, that is negative 1. So solving, let's equate to 0. X plus 1 equals 0. Then solve for x. X is equal to negative 1. Therefore, the domain is x is an element of R such that x is not equal to negative 1. So ulitin natin, all the values can take the variable x except negative 1 because the denominator becomes 0 and f of x will be undefined. And the interval notation can also be written as the domain is from negative infinity to 1, union negative infinity to positive infinity. Take note that negative 1 is not included in the solution set. Next, we have to find the range. The same case, what do we do is we change y with f of x, or we change f of x to y. That is, we have x plus 1. We can first simplify. We have x squared minus 3x minus 4 can be factored as x plus 1 times x minus 4 all over x plus 1. And since x plus 1 is a common factor in the numerator and in the denominator, you can cancel the 2x plus 1 here to come up only with y is equal to x minus 4. And then solving, we substitute x is equal to negative 1 to find y. Where did we get negative 1? From the unknown kanina, that is the undefined value of x. So you can have y is equal to negative 1 minus 4, y is equal to negative 5. And therefore, what is the range? The range is element of R, y is not equal to negative 5. And the interval notation, negative 8 to negative infinity to negative 5, union negative 5 to positive infinity. That would be all for this lesson.